triangle, right? We're supposed to determine the size of P1, which is this one here, okay? And we are told that PQ is equal to QR, so this side is equal to that side. What comes into your mind? Don't use the reason base angle. You can't tell me that even your teacher is teaching you using base angle. I doubt that. Uh-huh. So if I want to find P1, my suggestion is find the size of angle R1 first. If this is X, right, OQ is a radius, and OR is also what? A radius. So we'll say in triangle, OQR, right? If you're dealing with triangles, always identify the triangle and name the triangle. Identify the triangle and name the what? The triangle. So in triangle OQR, this is OQR, we are given angle X. So I will say OQ is equal to OR. Why? These are radii. Okay? They are radii of the same. Alright? Now, once you are then you write this down here, what this means is you can say therefore, angle Q is equal to angle R1. Both are equal to X. And your reason will be angles opposite equal 7. Okay? Not base angles of an isosceles. That's the same thing. It's not the same. It's not the same. The reason why we don't say base angles of an isosceles, we cannot rush to say it's an isosceles. We may need to prove that this angle here is not equal to both these two. Okay. Here we are not, because when you are in grade 8, you are in a lower grade. Now you are in a higher grade, you must think like someone who is in a higher grade. So forget about base angles of an isosceles. Okay. So I'm sure you can see the layout. In triangle OQR, then you identify your two radii. Then you say that those angles are equal. Right? Once I know that angle R1 is equal to X, that will make things easier for me. Right? I have to calculate now this angle here. Why do I have to calculate that? Because QR, it's a chord. It subtends angle O1 and angle P1. So angle at center is 2 times angle at circumference. Why is angle P? Okay, it's not Q, but you have to write it as O. I can write it as OQR. It just says that way. It's OQR, it's not entirely Q. It's OQR. Or rather, I think they labeled it as Q1. Yeah, it's labeled as Q1. Okay, let's put Q1 there. Let's put Q1 there. So this will be what? Q1. Put Q1. Be more specific. It's very important for you to be very specific about your angles. So Q1 is equal to X. Yes. So X is equal. So if Q1 is what R1 means, R1 is also equal to X. Alright. Are you all clear with this part? Please, if you have got a question, you have got an opportunity to ask. Yes. Yes, sir. Now, if R1 is equal to P1, how that equal to P1? Yeah, to find P1, because that's the objective. I have to find this angle or to first. Huh? Yes, I'm not finished. Because the question I need to find P1 in terms of X. So far I have used my knowledge of triangles. Now I need to use theorem 1, 2. But use theorem 2, you must see that QR is a chord. Okay? It's a chord. It is a line which joins 2 points on the circumference. So if a chord subtends an angle at the center, that angle will be 2 times the angle at the circumference. And this angle is also subtended by chord QR. Right. Okay. Do you all know what the word subtend means? All right. Okay. If you have a circle, right, if I draw, say, a triangle, make it at angles at the circumference, I'll just give you it's one of the simplest situations. See this angle here, if I call it angle A, this one I call it angle B. Right. Those two angles, they are going to be equal. Based on theorem 4, angles in the what? Same segment. Why are they equal? The reason is because they are subtended by the same chord. By the way, subtend, we mean there is a chord here which I can call CD. You see this CD here, to form angle A, the two line segments originate from CD. This angle here. You see this? Also, to form angle what? B, the two lines originate from that chord, CD. So we say CD subtends angle A because the two, for angle A to be formed, the two lines originate from what? A chord, and that chord in this case it will be CD. So also to form angle B, okay, it can only be formed because of the chord CD. It is a line of a chord that causes the formation of this angle at the circumference. Furthermore, okay, wait, an angle can also be subtended by an arc. Okay? An angle can also be subtended by an arc. So this arc here, arc CD, it also subtends angle A and angle B because the two line segments that form those two angles, they originate from the arc, they also originate from the chord. So you will need to go. No, you don't get it. Remember I told you, Tando, that there are two types of chords. There are visible chords. They are already drawn. Like in this case here, chord QR is drawn. Okay? There are times when the chord won't be drawn. But if you see that there are 2 points on the circumference, you can construct an invisible chord. So the invisible is chord C is subtends and A. Yes. Yes. The same chord subtends what? Two angles. If you use like which reason? What do you just say? Subtend. No, you write it down. I don't know how to write it correctly. Okay, look here. These two angles are equal because they are subtended by the same chord. They are subtended by the same chord at the circumference. No. The way produced subtend is this. Yes. The word produced in geometry, it means if I draw a line like AC, then I carry all like that. Then I give this point to a point. It means AC is produced what? To E. So be very careful with the terminology. Okay? So here, let's come back here. For me to get angle P1, I need to find the size of angle O. I is P1. So doesn't the shape over there, so doesn't mean that the angle O1 is down P1. Yes, it is. Why is it double? Based on theorem what? Theorem 2. Angle at the center is 2 times angle at the circumference. So can you say that? Or 2 is equal to 2x from exterior angles of power, then it's O1 equals to 180 times 2x. Okay, I think that could be possible. Or 2 is an exterior angle of a triangle, so it's equal to x plus x, which is what? 2x. And then? Then I say that 2x out of P1 equals O1 equals to 180 minus 2x. Yeah, fine. But in my case, I'm going to use the triangle. So I'm going to use triangle OQR. In that triangle, if I add Q1 plus R1 plus O1, you get what? 180 degrees. And the reason sum of angles in a triangle. Yeah, do you see the triangle? There is still the same triangle OQR. But now, this triangle, Q1 is X, R1 is X. You want to get what? O1. So what this means is that I can say, therefore, X plus X gives me what? 2X. Which means O1 is not equal to 1/8 minus what? 2X. Are you following? Please, I just want you to be aware that before you write on Friday, this is your opportunity to have a detailed lesson on this. If you have got a question, then you can ask. I wish when I send you the worksheet, you would have done it, but would have been more productive to you. Because you would have written down your answers and then we have to do this discussion. It was going to help me more. Alright? So can I carry on here? Yeah. Now that I found the angle at the center, I know that based on theorem 2, angle at the center is 2 times angle at the circumference. It means O1 is 2 times angle P1. So I'm going to write here and say P1 is equal to half of O1. Okay? It's the same thing as writing O1 is equal to 2 times P. In my reason here, it's angle at center equal to 2 times angle at circumference. But what is O1? That's half times this answer here. Yes. Okay, look here. Angle O1 is subtended by chord QR. Angle P1 is subtended by chord QR. But P1 is at the circumference and O1 is at the center. An angle at the center is 2 times the angle at the circumference, which means angle P is half of O1. Huh? Yes, one is at the center, subtended by the same chord as the one which is at the circumference. Why is it also equal to? No. Because O2 is not subtended by the same chord as P1. Okay, look here. Well, I hope you. Oh, okay. I see. This is what we are talking about. I would suggest that when you come on Friday to write your test, maybe bring a highlighter so that you can be able to highlight it. Okay. Right? Okay, so we are here now. So this is times 180 minus what? 2x. This should not confuse you. Half of 180 is what? Half of 2x. And then you are done. Okay. Now, when you're answering this question, don't get scared. In my opinion, I feel like geometry is not like as difficult as what people think. You can make it difficult on your own. Know your geometry concepts. Have a strategy in terms of how you approach the questions. Have a strategy. Know what to look for. Right, so we are done with this one. Let's move on to the next one. Now the next one says prove that line TQ bisects PQR. So line TQ is this one here. Okay? If it bisects angle PQR means Q2 is also equal to what? X. So we have to prove that Q2 is equal to X. Okay? Once you prove that Q2 is equal to X, then it makes things very, very easy. Fortunately, we know that PQ is equal to QR. We know that. Already we now know that this angle is 90 degrees minus x. Okay, we know that R1 is x. Okay? Yes, we remember we proved that already. Okay. Don't forget that usually the geometry questions have got a connection. The geometry question has a what? Connection. So what this means is this whole angle here is also equal to P1. So I would say in triangle PQR, right? PQ is equal to QR. This is given, right? This is given. You get marks for that. You might get a mark for it because 7 marks, so you might get a mark for it. But what the statement is easy. So then I can say, therefore, angle P1 is equal to angle, I'll call it PRQ. My reason is angle opposite equals. What this means is that PRQ is equal to 90 degrees minus. Your question? Remember the goal to prove that Q2 is equal to X. That's where I'm trying to get to. Okay? We follow this. Right. Now, the next thing now is trying to determine the size of this angle here in terms of X. Okay? That's the next thing that I have to do. I need to prove to determine what? That Q2, this Q2 here is equal to, is equal to X.
You know this angle Q is equal to 90 minus x. And then angle Q2 is like x plus x.
Yes, you see, we are given in the question that PQ is equal to QR, right? So in triangle PQR, that means this whole angle here is going to be equal to P1. But when we found P1 is 90 minus what? Minus x. Therefore, the whole angle R1 plus R2 is equal to 90 minus what? Minus x. Then I'm almost done. All I have to do is say, in that same triangle, if I add angle P, right, 1 plus angle Q, 1 plus Q2 plus angle R, well, I can call that one, I can call it that PRQ. I must get what? 180. In my reason here, sum of angle left triangle. Okay? This is 90 degrees minus x. These two are both equal to 2x. PRQ is 90 degrees minus x. That will give me 180. Right? Well, I made a mistake. I was supposed to put Q1 is x. I made a mistake. I didn't correct that. Correct. Alright. So this is plus Q1 is x, but Q2 we don't know, right? We just need to prove that Q2 is x. That's the goal. So I'm sure you can agree with me that some of the terms can cancel out. This minus x and that x will cancel. Does that make sense? right? Then 90 plus 90, so we end up having Q2 plus 180 degrees minus x is equal to 180 degrees. Then we take these two terms to the what? To the right. Then we end up having Q2 is equal to 180 degrees minus 180 degrees plus x. These two cancel out. Eventually, you get Q2 being equal to, which is equal to what? Q1. Then you can make a deduction there and say, therefore, TQ, okay, bisects PQR. Bisect PQR because the main reason is because Q2 is equal to X, right? Q1 already substitute the X here. Yeah. But I think what I would suggest is somewhere at the beginning there, you must also write that Q1 is equal to X, then that's given. Okay, then you can relate now this and that. Then you are done. Always identify triangles as well. Okay, don't worry about copying this. I'll send you a PDF on the WhatsApp. Follow me. Sum of angles in a triangle, angles opposite equal sides. Those are very important concepts that you should know. Okay? For your core control test, don't worry about theorem 1 because it's not going to test it. But theorem 2 up to theorem 9, yes. Don't need to worry about it. Waiting. No, the control test will probably be 75% of the term mark.
So you will take your log and your assignments and you can modify
That's true.
how much you have for the term.
Okay, let's go over this one now. Okay, when you've got a question like this where you've got a tangent, what must come into your mind? Tan chord theory. Tan chord theory. Whenever I see a circle and there's a tangent drawn to it, tan chord theory, right? So we have got a tangent, that's RT there. Okay, we're also given that RS is equal to RT. So let's just indicate what we are given here. So RS, okay, this one here is equal to RT. So those two are equal. Okay? And we are also given that T4 is equal to X. So it says give with reason 3 other angles equal to X. Right? T4 is this angle here. Right? The first angle that I can see is T1. Okay? The first angle that I'm seeing straight away, I'm seeing T1. I don't know what angle you are seeing. Okay? It's fine if you're seeing another angle. So in my case, for 6.1, I would say angle T1 is equal to T4. Both are equal to X. The reason vertical opposite angles. Okay. Okay, generally this reason you have to put an equal sign for. For some reason, if you look at the examination guidelines there, when you write vertical opposite angles, you have to put an equal sign. Okay, whenever you use it. This one is unique, you have to put an equal. Okay, so we have got that first. The following day, then since T4 is an angle between a tangent and a chord which is Tn, it means this angle here, that M3, it's also equal to what? To x. Time code what? Time code theorem. You follow that? Remember, an angle between the tangent and the chord inside the circle, right? An angle which is subtended by the chord inside the circle is going to be equal to the angle between that chord and the tangent. The angle between the tangent and the chord is equal to the angle subtended by this chord, and that angle is that angle.
So, so what we can say angle R is equal to T4.
Angle what?
R1 is T4. R1.
That's what we said.
R1.
The whole angle is
This whole angle here is equal to T4 based on what?
so it's a T4 angle.
It's not in a circle.
Remember, angle R, that is R1 plus R2, is not inside the circle. So you can use any of the circle theorems now.
So
But if
you can say that angle RST equals x, angle equals R.
yeah. So first let me write that angle M3, I hope you saw this, is equal to T4. Both are equal. This is time code theorem. Right?
Also, angle is
Yeah, and then this angle here equals what? T1. Okay? So this, but before you write that, you don't need to write that first. You must write RS is equal to RT. This is what? This is given. Therefore, angle S is equal to T1 is equal to X, and the recent angles opposite the equal side. Okay? Not sides opposite equal. When you say sides opposite equal angles, means you'll be given the angles that are equal. You are trying to prove that the sides are equal. This is the opposite of this. It's the opposite of that. You following? Huh? Okay. Then, but where's the question? Okay, if you don't have a question, then let's carry on. Then 6.2.1 RST equal to 23. RST equal to 23. Alright, we have proved that already. So just say 6.2.
RST equals to everything.
And this will be proved in 6.1. Okay. Then now 6.22. Now, from my experience, when learners see a question like this, most learners think it's so difficult. Okay? But it's not. It's not. There are three ways of proving that a part is cyclic. Three ways. Okay? Three ways of proving that a part is cyclic. And here, we are supposed to prove that RSTM is a cyclic quadrilateral, which means we can draw a circle passing through the 4 points R, S, T, and M. That's what it means to say, prove that RSTM is a cyclic quadrilateral. It means we can draw a circle such that R, S, T, and M will be on the circumference. Alright. Now, do you see a butterfly there? Do you see a butterfly? You see a butterfly? If you see a butterfly, then you can use the converse of theorem 4. Converse angles in the same segment. But now, the thing is, if you see the butterfly, how are you going to prove that angle T1 is equal to M1?
So we want to just use exterior angles.
Yeah, but you see, I'm starting with the converse of theorem 4 first.
R is
R is what? It's not a circle yet. It's not inside the circle. Okay. So what that means is you can't use the converse of theorem what? Of theorem 4. Right. Right. You can't use the converse of theorem what? Theorem 4. It means you'll be left with the converse of opposite angles of a cyclic path are supplementary or exterior angle of a cyclic what? Of a cyclic path. Yes. One, you can, if you identify the butterfly, if this angle is equal to that angle, and that one is equal to that, then you can say it's a what? It's a cyclic path. Okay. Or in this case, if you can prove that, say, this angle is equal to that one, then it's also what? The cyclic path. If we add an exterior angle, when we wait, if this angle here is equal to that angle, it's also what? A cyclic path. Okay, yes. No, if they are opposite, they are supplementary.
So they have to be equal.
Look, if the opposite angles of a cyclic quad add up to 180, so the opposite angles of a quad add up to 180, then you can say therefore the quadrilateral is what? Cyclic. Remember, they are supposed to be supplementary. These two. If they add up 180, then you have a cyclic quad. Also, if an exterior angle of the quad is equal to an interior opposite angle, then you can say the quad is cyclic. Okay? So here, if you can prove that that one is equal to that, then you can say therefore the quad is cyclic. If you can prove that this angle here and that one there add up 180, then you can say the quad is cyclic.
So,
No.
and we see A is equal to L plus R1, because it's the right angle of cyclic path.
The same thing with what?
C3 angle R is equal to L R.
No. T3, this T3 here, it's not. Okay, how are you going to prove that it's equal to R1 plus R2?
This is what you just did.
Well, yes, if you can prove that indeed they are equal, then you can say the path is cyclic. But why are you taking a long route? Because already we have got this information. You see, the geometry questions, they have a connection. You see the answers we got here. You see the answers we got in part in 6.1. We can use that. This one here, M3 is equal to what? S. This one here. We also prove that angle S is equal to what? This one here. Most of the time, the first part of the question leads you to answers for the next question. Yeah, it will be M3 is equal to S. We have proved that already. So say M3 equal to S, both are equal to X. The reason proved in what? 6.1. Then you say, therefore, RS theory is a cyclic path.
So what's the reason?
We proved it. You can see M3 is X, M of S.
Yes.
Yeah, we proved it.
So, can you see all the no, so I want the reason with the theory angles.
Okay, don't worry, I'm going to write it down. So let me see if I have it. Yeah, I can do it here. So, first thing you say M3 is equal to angle S. Both are equal to X. This was proved in 6.1. Okay? Right? Then you start smiling, you get 1 mark for that. Then you say, therefore, RSTM is a cyclic quad. Cyclic quad. The reason you say converse exterior angle of the cyclic part. Right? This word here is the most important. That word converse is very, very important when you are proving that a quadrilateral is cyclic. Also, when you are proving that a tangent, so a line is a tangent, you have to use that word converse. Okay? Now, with the geometry equation, as I said earlier, they have a connection. Usually, the first part of a question, if a question has got divisions, what you do at the beginning, in most cases, you need to answer the questions at the bottom.
In our so, I'm going to be using or training